My name is Chris Applegate, and I'm a solution architect here at the Customer Solution Centers. Our mission in the Customer Solution Centers is to directly engage with customers to demonstrate the value of the Dell Technologies portfolio. In doing so, we've built a network of 19 locations throughout the globe, and these are places where you can have technical conversations with our subject matter experts. Perhaps those conversations are technical briefings that are up to an hour long. Maybe they're whiteboarding sessions that can be up to a half day long. Or finally, they can be proofs of concept that can extend anywhere from 1 to 2 weeks, where you actually kick the tires of our solutions prior to purchase. You can do all of this at no charge at any one of our network of solution centers throughout the globe. Today, I'm here to talk to you about the Kubernetes advantages from a Dell Technologies perspective. It's important that when we talk about these advantages, we first have to understand how we got here. We have to first understand the advantages of containers. When I think about the advantages of containers, I like to distill it down to what I call the 3 T's. The first one, and most important, is agility. If you think about this, a traditional VM is very, very thick, right? When you look at the different assets inside this, you have your operating system, you have your libraries, you have your application, and you have your data. And all of these are in a single entity. Versus a container, you're able to segment each one of those. Your operating system is in a different layer than your libraries. That's in a different layer than your application. And finally, that's in an even different layer than your data. I like to use the analogy of comparing this to preparing a soup versus preparing a sandwich. If I prepare a soup, much in the way that a virtual machine, I put everything into one big pot. And if somebody comes late to the party and they want to eat the soup, but they say, I'm allergic to carrots, that's already baked into the soup. I would have to remake the entire soup in order to serve them. Versus if I had served sandwiches, they could come in late to the party and say, I don't like this particular layer, I want to make a change to this one layer. That's fine, because they can just eliminate that one layer. The next T that we talk about is reproducibility. When I build something in a container, I can send that container to somebody else, and every time they follow the same exact steps, it's going to look exactly the same, right? It's highly reproducible so that I can start to build automation processes around that. And this reproducibility gives me the next T, portability. Right? Again, I can take this container and I can send it to a colleague, and they can reproduce the exact same artifact in exactly the same state. When I want to put something into production, I can take it from my development environment and send it up into my production environment. And again, it will be the same exact state. This artifact is very, very portable because I can reproduce it. Now that we understand the advantages of containers, let's talk a little bit about what Kubernetes advantages bring to the party. The first thing, at its core, Kubernetes is a container orchestration engine. So more than one container is hard to get your arms around. As you start to have tens, hundreds, or thousands of containers, you want to be able to orchestrate them into a symphony. And so Kubernetes manages all the infrastructure necessary to run those containers. And it does so by being open source, meaning that the code is easily auditable. It's developed in the open. If you want to add features or remove features, you can do so. If you want to fork it and maintain it yourself, you're given that level of freedom. And then finally, the last advantage of Kubernetes that we like to talk about is the fact that it's declarative in nature. When you think about declarative, I like to use the analogy of an autonomous vehicle, right? In a procedural format, if I wanted to get a autonomous vehicle from point A to point B, I could, in a procedural fashion, map out, go 200 yards forward, take a right-hand turn by 90 degrees, proceed another 25 yards forward, then a left-hand turn, right? Unfortunately, if construction happens, then my plan, my procedure is no longer valid, and I have to scrap effectively the whole thing. Versus in a declarative fashion, if I had simply told the car to start from point A and end at point B, using your own internal rule sets, make this happen, I do not care how, we free that car to go ahead and make all of the appropriate decisions to get it to its destination, right? Kubernetes is very much the same manner, where you say, I want to make sure there are always at least 3 instances of my particular database container running at any one time. I don't care what nodes you put that on. I don't care if they're coming or going. I just need you to make this happen. Then Kubernetes uses its internal controllers to enforce that and make it happen. Right? So now let's talk a little bit about the infrastructure needs that you have for Kubernetes. Well, you first have to make the decision if you're going to run this in virtual machines or you're going to run it in bare metal. And when you run it in virtual machines, oftentimes you're running it on an infrastructure as a service. Right? The next thing you need is you need some level of persistent storage. Right? When you want to preserve the state of, say, your database containers, you're going to want those to persist through as containers come and go. That declarative nature being enforced by the controllers means that when a node fails, it's going to restart a container on another node. You're going to want it to be able to take that persistent storage with it. Right? The next thing you need is you're going to need a robust network. And this is where we start to see people incorporate software-defined networking technology, and ideally things that can provide full network segmentation. And so when we look at technology like microsegmentation inside your software-defined network, I like to use the analogy of traditional networking and security is like a castle, and network segmentation or microsegmentation is like a hotel. If you think about it from a security standpoint on a castle, you're going to go ahead and build a robust moat around that castle, and you'll have a drawbridge, and you'll have guards that are pointing weapons at that drawbridge, and will prevent anybody from coming in through that drawbridge. But who's there to prevent the jester, who might already be inside the castle, from killing the king? He's already inside the castle. Now contrast that to a hotel, right? Much like microsegmentation, a hotel, you can walk into the public lobby, but your room key only gets you into your room and only while you have a reservation, right? Software-defined networking microsegmentation works the same way in that it secures, making sure that the right containers only talk to the other right containers while they have a valid reservation. Now that we understand what the potential advantages of containers are, how Kubernetes can assist with that, and finally what types of infrastructure you need, let's talk a little bit about how Dell Technologies can help here. Our mission at Dell Technologies is to be the leading partner in order for you to be able to stand up cloud-native Kubernetes infrastructure. And when we talk about that, it extends into 3 areas. We want the ability to help you build, run, and manage your cloud-native Kubernetes infrastructure. Let's focus first on build. Right? Inside build, we've partnered with our colleagues at Pivotal in order to deliver a way to give you the appropriate people training, and we train them how to use the appropriate processes and the appropriate tool sets in order to be successful when building cloud-native Kubernetes infrastructure and applications. The other partnership is inside VMware. They recently acquired Bitnami. Bitnami is already the leading enterprise container catalog. Now that we're able to bring them inside the family, this gives you a secure enterprise container catalog allowing all of your developers to pull from known good configurations and images as they're building out their individual workloads. Now let's shift to running Kubernetes infrastructure. There's a variety of options here, right? We start with Pivotal's container service, PKS. This gives you the ability to stand up not just one Kubernetes cluster, but many different Kubernetes clusters and manage their lifecycle and access parameters. We also look at the announced Project Pacific that's going to make its way into vSphere 7. And this allows you to run containers and Kubernetes pods as first-class citizens directly alongside the virtual machines you're all running today. But it doesn't forsake the ability to run those virtual machines because you can run them as equal peers. Next, we look to storage for persistent storage. We use the storage container storage interface, the CSI, and we have the ability to present persistent storage from a multitude of different offerings inside Dell Technologies, extending from our PowerMax SANs, right, our Extreme I/O devices, our Unity devices, our vFlex software-defined storage, and even, obviously, in VMware's vSAN. Right? You can use any one of these storage technologies to back the persistent data stores inside your Kubernetes clusters. Right? And finally, we talk about networking. We have VMware's software-defined networking solution, NSXT. This is what gives you that secure network with full microsegmentation support, allowing you to build those secure applications on Kubernetes infrastructure. Now, when we look to managing this infrastructure, you're going to have a couple of different problems. The first one is just getting visibility into your Kubernetes clusters. Kubernetes tends to be highly command line driven, so having some form of management dashboard is tremendously helpful. We start with the open source VMware Octant solution. This is free of charge, and it works on Kubernetes, whether they're Kubernetes provided by PKS, Pacific, or if they're just generic upstream Kubernetes, or even any of our competitors in the cloud or on premises. This gives you that dashboard, that secure dashboard, to actually see what pods are running, what services are running, what their endpoints are, and even make some of those changes inside that raw YAML manifests. Next, we look to, as I start to build out my Kubernetes infrastructure, I'm not going to build just one Kubernetes cluster, but in fact, I'm going to have a multitude of clusters on different clouds, servicing different lines of business, servicing different security needs. But my problem is I want a level of consistency to be able to be weaved through all of those locations. I want to make sure that authentication and security policies are enforced. I want to make sure things like storage policies are enforced and are consistent across all the locations, across all those clusters. This is where Tanzu Mission Control from VMware comes in. It provides that ability to manage both policy, storage, and security, as well as get the ability to even deploy those clusters on premises in your existing data centers or even in our public cloud partners. So hopefully you've seen here what the advantages of Kubernetes can bring to the party, and how Dell Technology has the widest portfolio for us to be able to be the leader in allowing you to build, run, and manage your cloud-native Kubernetes infrastructure. If you have any questions about this, please don't hesitate to reach out to your Dell account team to engage with the customer solution centers and come have a conversation with our subject matter experts about this. Even see demonstrations and maybe even kick the tires of some of these solutions prior to purchase. Again, all of this is available at no charge to any Dell Technologies customers. Thank you.